All right, this is the matrix quiz review sheet. I'm going to go through each problem individually. If you want to go ahead and fast forward and find the problem that you specifically need, you're welcome to do that. We're going to start with matrix addition in part A plus B. So the first thing you want to check on is that A and B are both the same size matrix. Since they are both a 2 by 3 matrix, we can definitely add those together. And when we add them, we just add their like parts. So the -1 will correspond to 7. So -1 plus 7 is 6, and so on and so forth. Then we go to the 2. Add it to the 1. 2 plus 1 is 3. Then we go to the 0 here. Add it to the -3. 0 plus -3 is -3, and that's row 1. And we do the same thing with the bottom row. 4 plus 2 is 6. 5 plus 0 is 5, and 3 plus 6 is 9. Similar on letter B is just C minus D. So instead of subtraction, you're going to, instead of addition, you're going to do subtraction. You again have to make sure that they are the same size. Since they're both a 2 by 2, you're good to go and go ahead and subtract these. So we're going to start with 1 minus 11, which is -10. Then 2 minus 5 is -3. Same thing on that bottom row. -4 minus 0, and 9 minus a -2. That's like 9 plus 2, which is 11. Next is A plus E. So again, check the size. We have a 2 by 3, and we have a 3 by 2. Since those are not the same size, this is undefined. We cannot add those together. Letter D is scalar multiplication, so we're going to do 3 times matrix A. So if we write that out, we put a 3 in front, and this is a lot like the distributive property. So we're going to distribute the 3 to every number inside. So we end up with -3, 6, and 0, 12, 15, and 9. So again, each one of those entries was multiplied by 3. Letter E, we have 2 times C. So that is scalar multiplication plus, so we're going to do a matrix addition as well. You want to make sure that C and D are the same size because you're going to end up adding those together. And they are a 2 by 2, so we can definitely add those. So first we're going to do 2 times C. And we're going to add it to D. Oops, that was it. So here, everything inside gets multiplied by 2. And we're going to add it to matrix D. So again, when we add matrices, we look to add the like entries. So 2 is going to be added to 11, 4 is added to 5, -8 to 0, and 18 to -2. So we end up with 13, 9, -8, 18, plus the -2 is like 18 minus 2, which would be 16. All right, our next one is 5b minus 4a. So again, make sure that those are the same size. Since they are both 2 by 3s, you're going to be able to subtract those eventually. But first we have to multiply them by their scalars. Give myself a little bit more room here. All right, so we're going to take A and we're going to multiply everything by 5. So -1 times 5 is -5. 2 times 5 is 10. 0 times 5 is 0. 4 times 5 is 20. 5 times 5 is 25. And 3 times 5 is 15. And then 5b, oh, we were supposed to do 4a. Let's go back. We were supposed to do 4a. I am so sorry. So 4 times negative 1, 4 times 2, 0, 4 times 4, 4 times 5, and 4 times 3. Okay, and then we're doing 5b. So 5b, we would get 7 times 5, 1 times 5, negative 3 times 5, 2 times 5, 5 times 0, 5 times 6. Okay, now that we have the correct matrices, we're going to go ahead and subtract these. So if you keep in mind, you have to do it in order. It's 5b minus 4a. So I'm going to go ahead and write those down. All right, so again, when we do subtraction, we just do like areas. So 35 with the negative 4, 5 with the 8, negative 15 with the 0, 10 and the 16, 0 and the 20, negative 30 and the 12. So 35 minus negative 4 is like 35 plus 4. 5 minus 8 would be negative 3. Negative 15 minus 0 is negative 15. And then we have the bottom row. 10 minus 16 is negative 6. 0 minus 20 is negative 20. And then, is that negative? I think I should have just done positive 30. Yeah, positive 30. Positive 30 minus 12 is 18, and that would be your final answer. All right, now we have matrix multiplication. So we have A and B. So this is a 2 by 3 and a 2 by 3. When we do matrix multiplication, we always look at these inside numbers. If those numbers are the same, we can multiply. Okay, so same means that you can multiply. Different, okay, means that we cannot multiply. So we call this undefined. So this one we definitely cannot do. And now we can check D and B. So D is a 2 by 2. B is a 2 by 3. So if we look in here, guess what? We're good to go. We can multiply those. Our result is going to be these two numbers on the outside. So our resulting matrix will be a 2 by 3 matrix. So I'm going to go ahead and rewrite my D. Oops. I'm going to go ahead and rewrite my D times B here. Okay, so when we multiply, we do row by column. Row by column. So this is a row and this is a column. So I'm going to do 11 times 7 plus 5 times 2. So you always do corresponding. So first entry with first entry, second entry with second entry. Then I'm going to go back and I'm going to do first row again times second column. So it'll be 11 times 1 plus 5 times 0. And then we're going to do the third column. So I'm going to go third column here with this guy here. So I have 11 times negative 3 plus 5 times 6. And that's my first row. Now we're going to take the second row and we're going to do the exact same thing. We're going to multiply it to each of these columns. So I have 0 times 7 plus negative 2 times 2. And then we're going to go to the second row. 0 times 1 plus negative 2 times 0. And then 0 times negative 3 plus negative 2 times 6. And if you look, we're going to end up with a 2 by 3 here. So you can put each of these into your calculator. Each of those are an entry. You can put each of those in your calculator, or you can do it by hand. Totally up to you. If you do it in your calculator, okay, or by hand, you should end up with the same exact answer. So you should end up with 87, 11, negative 3, negative 4, 0, and negative 12. So really quick, I'm just going to go over one entry with you so you kind of see how I do this. So this would be 77 plus 10, and that's how I got my 87 here. So then you would go through each one, do that, and that's how you would get the entries. All right, now we're going to practice finding an inverse. To find an inverse, okay, so you want to find A inverse. Here's our equation for that. Okay, so we switch A and D, and then make B and C a negative. So let's call this matrix A. If we want to find the inverse, okay, we start with that first part. 1 over the determinant, AD minus BC. So if I look here, A times D is going to be 3 times negative 2. Minus BC. So that is negative 6 times 7. And then we go ahead and we flip our matrix. So what we're going to do first is we're going to take these two guys and we're going to change their locations. So now my negative 1 is here and my 12 is here. So we just flip those. Then, for these two, we just change their signs. So that the positive 3 becomes negative 3, the negative 4 becomes positive 4. And then from here, it's really just simplifying. So we're going to go ahead and simplify our denominator. So we'd have negative 6 minus a negative 42. So that would be 1 over 36. And then I'm going to go ahead and bring down my matrix. And from here, it's just like scalar multiplication. You multiply the whole thing by 1 over 36. So this would be negative 1 over 36. This guy would be negative 3 over 36. Oh my gosh, too many mistakes. I'm sorry guys, I used the wrong matrix. This fooled me. Let's get rid of this guy. Okay, I'm just going to cross him out because he's got me all confused. Okay, we need to use the first matrix. That's okay. We did find on this part, I just used the wrong numbers here. So we would have, I'm going to switch my 3 and my negative 2, and then I'm going to change my signs on my 6 and my negative 7. Okay, so we'd have 1 over 36 with our matrix. All right, so I would distribute my 1 over 36 in. So I'd have 2 over 36, 6 over 36, negative 7 over 36, and 3 over 36. Now, those can actually be reduced. So if you go into your calculator, you can enter each fraction and then hit math, enter, enter, and it'll change it to a reduced fraction for you. But if you want those reduced fractions here, this is what they would look like. And that's your final answer for number 2. And I am going to condense this and we'll move on to number 3 here. Okay, let's move on to number 3. So it's the same process. We'll call this matrix B. So again, right here, 1 times, negative 1 times 12 is negative 12. 3 times negative 4 is also negative 12. And then we're going to go ahead and we're going to write our matrix. So for this one, the 12 and the negative 1, we just flip their locations. And the 3 and the negative 4, we just flip their signs. Now, what happens here is we end up with 1 over 0. Negative 12 plus 12 is 0. When this happens, okay, this tells us that there is no inverse for this matrix. So when there's no inverse, we call it singular. And there's nothing else we can do. All right, our last question here, solve the system using inverse matrices. So what you're going to do is you're going to go ahead and you're going to write down matrix A, matrix X, and matrix B. Matrix A is the coefficients, matrix X is your variables, and matrix B is everything on the right-hand side of the equal to sign. So the first thing I'm going to do is I'm going to write the overall augmented matrix. Okay, so A is just going to be everything on the left-hand side of the equal sign. And then if we look at what our original system, we have X, Y, and Z. So that's what goes in here. And then on the right-hand side of the equal sign are our negative 2, our 4, and our negative 5. Okay, now we're going to go into our calculator and enter these into the matrix feature in our calculator. So go ahead and pull that up. Okay, second matrix. I'm going to go over to edit. And then matrix A is a 3 by 3 matrix. So we're going to go ahead and enter those numbers. And then second matrix again, go over to edit and enter matrix B. We will not enter matrix X. We will only enter matrix A and matrix B. Matrix B is a 3 by 1. And there's matrix B. Once you have those done, press second mode, and we're going to continue. If you need to pause and go back to walking through that, go ahead and do that now. All right, so what we do on our notes is we are going to take A times A1. Okay, and then over here we're going to do B times A1, or A1 times B. These both will give us 2 matrices that we need to have. So in our calculator first, we're going to do just both of those. So you need to be on your original screen. Second quit will get you there, second mode. So go and go press second matrix, choose A, and then right here where we typically press matrix, if you just press that button by itself, that gives us our inverse matrix. Then choose times, second matrix, choose A again. This is A1 times A. Press enter. This is called the identity matrix, and that should happen every single time you multiply a matrix by its inverse, which is what we just did. Then we're going to do second matrix, and we're going to do A1 times B. So A1 again, times second matrix, and this time we want B. And that gives us those numbers there. Okay, so when we go back to our notes, we're going to record that. So here we had the identity matrix. Identity matrix is where you have zeros in the everywhere else and then ones in your main diagonal. We're going to go ahead and bring down matrix X, and then matrix B gave us this, and these are actually your answers. So if you look across this first row, this is like X equals negative 82. The second row, Y equals 51. Third row, Z equals 104. So when you write this as an answer, we have negative 82, comma 51, comma 104, and that's